Hi, let's go over an example for means. Suppose that elephants have a mean weight of 1,350 kilograms with a standard deviation of 120. We take a random sample of 121 elephants. What is the probability that the average weight is less than 1,320 kilograms? Okay, so first let's point out what is our population um, mean and what is our sample mean. So taking a look over here, we can see that 1,350 kilograms, that is our population mean, so our mu. And the standard deviation is given as 120. That is our population. Now, if we take a random sample of size n, 121 elephants, that weight is, what is the probability that that average weight is less than 1320? So it's important to point out that 1320 right here, this is our sample weight. The first thing we want to do is state and check our conditions. We want to state and check in conditions because once the conditions are met, we can use a normal model. So the first condition is that it needs to be stated somewhere that it's random. If it's not stated, you want to assume that your sample was taken randomly. So it was stated right here that it was taken random. The next thing we want to do, step 2, is to show that our sample size is either greater than or equal to 30, or if your sample size is not greater than or equal to 30, it needs to be stated somewhere that it was taken from a normal model. But in this case, our sample size is 121 right here. This is our sample size, 121, and that is greater than or equal to 30. So both two conditions, the first two conditions are met. Third condition is that the population is greater than or equal to 10 times n. 10 times 121 is 1210. So that condition is met. We want to say there are more than 1,210 elephants in the population. Condition met, we will use a normal model. Now, what is our normal model? Our normal model contains the population mean, which will be equal to our sample mean. So that is 1,350. But be careful with the standard deviation. The standard deviation is from our sampling, and that is given as the standard deviation of the population divided by the square root of our sample size, which is 121. So working this out, we get that our sampling standard deviation, 10.9. Drawing our model, we could see that here we have our population mean will be equal to our sampling mean, 1,350. And we want to know where it is 1320 or less. So here it is. I have it shaded to the left. Now imagine that we had many, many different samplings here. So these are all samples, and therefore this is our sampling distribution. Our X bar are samples of 121. All right, using our z-score, we want to know where we are on the curve. So our z-score is the mean, our statistic, which is X bar minus the mean of the parameter over our standard deviation of our statistic. Calculating this, we get is negative 2.75, which makes sense because on our model, which is why it's important to draw our model, this kind of double checks your work. We have that our X bar is right here in our distribution. Now looking at our z-score, that is about negative 2 here, and so it makes sense that our z-score right here is negative 2.75. Now to take that area that is shaded here, we can go ahead and use our calculator, or you can use a table. If you use a table, you're going to look at your z-score. If you use a calculator, we will use norm CDF, lower bound, upper bound, the mean and standard deviation. Now, what is our lower bound? Well, that's just our area to the left, which is negative infinity. If you don't have negative infinity in your calculator, you can just put in negative 999, as many nines as you want. This right here is our upper bound, which was our statistic, our mean right here. This is our mean of the population, and this is our sampling statistics, sampling distribution. So when you calculate this on your calculator, you will get that the probability is 0.00295. So then to answer the question, a complete sentence, you will say that the probability of selecting a sample size with an average weight less than 1,320 kilograms is 0.00295, or about 0.3%.